Welcome to the Explainer. Today, we're totally mastering elasticity. It's essentially the ultimate metric of how markets breathe, flex, and, well, occasionally snap. We're going to visualize exactly how human behavior and factory production actually translate into data.
Okay, let's dive right into this. We've got four main pillars today: price elasticity of demand, income elasticity of demand, cross-price elasticity, and finally, price elasticity of supply.
Section 1. Price elasticity of demand. How buyers react to the price tag. So here's our core formula. Price elasticity of demand measures exactly how responsive buyers are to price changes. It's calculated super simply as the percentage change in quantity demanded divided by the percentage change in price. Keep this ratio in the back of your mind because it literally dictates the shape of every single curve we're about to look at. And this brilliantly illustrates the absolute extremes of consumer behavior. On the left, we've got perfectly inelastic demand. It's that completely vertical line where elasticity equals zero. The quantity demanded stays exactly the same at Q1, totally regardless of the price. Think of a life-saving medication with zero substitutes. A patient is going to pay literally anything to survive. Now on the right, we have perfectly elastic demand, which is a horizontal line where elasticity is infinity. Here, consumers will buy varying quantities at exactly $50. But man, if a seller raises their price by even a fraction, demand plummets instantly to zero. This happens in a perfectly competitive market, like for a specific grade of wheat, where identical sellers are everywhere, so buyers just walk away to the next guy.
Stepping away from the absolute extremes, take a look at this steep downward curve. This represents inelastic demand, where the value is less than 1. Consumers are relatively unresponsive to price adjustments here. Notice how a massive 85.7% price surge from $35 up to $65 only causes a 40% drop in quantity. We see this all the time with daily necessities. For instance, eggs have an elasticity of 0.1, and healthcare sits around 0.2. Even if the price jumps, you simply can't cut back significantly on those essentials.
Now, here we have a very specific, perfectly balanced curve known as a rectangular hyperbola. This is unit elastic demand, where elasticity equals exactly 1. The quantity moves proportionally identical to the price change. So if the price of a good increases by 22%, the quantity demanded falls by exactly 22%. Because those movements perfectly offset each other, the total amount of money consumers spend in this market remains entirely constant.
Now, what's really interesting about this slide is how flat the curve is. This represents elastic demand, where the value is greater than 1. Meaning consumers are highly responsive. Just a minor price drop of 22% triggers a massive 50% surge in demand. Why? Well, because these are goods with tons of close substitutes. The data shows Mountain Dew has an incredibly high elasticity of 4.4, and Cheerios is at 3.7. If the price ticks up even a little, consumers just effortlessly switch to another brand. No big deal.
These curve shapes literally dictate survival for businesses. Let's look at the total revenue implications. If demand is greater than 1, meaning it's elastic, price and total revenue actually move in opposite directions. For instance, if you apply a luxury tax to yachts, sure, the price goes up, but demand crashes so hard that total revenue for boat builders actually declines. Conversely, if demand is less than 1 or inelastic, price and revenue move in the same direction. This creates a really fascinating paradox. Think of a Kansas wheat farmer dealing in basic, inelastic foodstuffs. An abundant, amazing harvest drops the market price, which actually results in a decrease in total revenue for the entire farming community. Crazy, right?
Section 2. Income elasticity of demand. How paychecks change habits.
Okay, so our baseline formula here is income elasticity of demand. That's the percentage change in quantity demanded divided by the percentage change in income. This tracks the everyday reality of life. Like, if you lose your job and your income falls, you're probably going to buy less ice cream. And when that happens, ice cream is categorized as a normal good. For normal goods, we see two distinct patterns. First, this steep, upward-sloping angle curve represents a small positive elasticity, landing somewhere between 0 and 1. Notice how income more than doubles from 30 to 70, but the quantity demanded only extends slightly, just from 46 to 54. This basically applies to day-to-day necessities like food and clothing. Families always need to eat, so even if they get a huge promotion at work, they don't drastically surge the physical volume of their grocery purchases.
Contrast that with this flatter curve, which represents a large positive elasticity, so greater than 1.
Here, that exact same income jump from 30 to 70 creates a massive disproportionate push in quantity, stretching from 37 all the way to 73. This is the realm of the luxuries: sailboats, caviar, diamond jewelry. Consumers willingly skip these when they're broke, for sure, but the moment their purchasing power skyrockets, they totally binge.
But what happens when getting richer actually makes you buy less of something? That gives us this downward sloping curve, representing a negative elasticity. This defines an inferior good. As income expands, the quantity demanded drops off significantly. A perfect example is bus rides. As a person's income climbs, they drop low-cost public transit to buy their own car. Or maybe they just start using ride-sharing options instead.
Let's move to Section 3 and see how this builds. Cross-price elasticity, the shelf tug-of-war. The formula gets a bit wider here. Cross-price elasticity of demand is the percentage change in the quantity demanded of good 1 divided by the percentage change in the price of an entirely different product, good 2. We are quite literally measuring the ripple effect one product has on another. Comparing these two relationships, on the left, we have a positive result for substitutes. If hamburgers get way more expensive, jumping from $2 to $6, consumers drop them, and the demand for cheaper hot dogs surges from 20 to 50. You see this everywhere. If frozen yogurt gets cheaper, you buy more yogurt, but you also buy less ice cream because they satisfy the exact same craving. But on the right, we have a negative result for complements. If the price of computers jumps from $2 to $6, the demand for software drops off heavily. They're paired goods. If computers become just too costly to buy, people naturally stop buying the software required to run them.
Section 4. Price elasticity of supply, flipping the camera to the factory.
All right, so this is the price elasticity of supply. The formula is the percentage change in quantity supplied divided by the percentage change in price. Simply put, this is our metric for how fast sellers can scale their output when financial incentives change.
So the crucial point is comparing these two extremes on the supply side. On the left is perfectly inelastic supply, a completely rigid vertical line. Quantity is permanently locked regardless of price. Why? Because it represents naturally finite commodities like beachfront land. To quote Mark Twain, buy land, they're not making it anymore. On the right, though, is perfectly elastic supply, a horizontal plane. Here, a baseline market price makes it highly profitable for firms with infinite idle capacity, like unused plants and equipment, to suddenly switch dormant machinery back on, supplying endless quantity at that locked price.
Looking at real-world constraints, the steep curve right here is inelastic supply, where the value is less than 1. A massive surge in price, say from $46 to $82, only yields a tiny bump in supply. This dynamic maps perfectly to the world oil market in the short run. Even if oil prices completely skyrocket, extraction capacity, known reserves, and fixed drilling lines just cannot be magically expanded overnight.
Now, with unit elastic supply, we see a perfectly straight line originating directly from zero. Any percentage change in price leads to an identically proportional change in supply. As the price expands by 100%, surging from 10 to 20, supply perfectly matches it, increasing 100% from 10 to 20 as well. This perfectly balanced responsiveness defines mid-range manufacturing and livestock markets over the medium term, adjusting in absolute lockstep with the market.
Finally, we've got elastic supply, a flatter curve, where the value is greater than 1. A modest price increase triggers a rapid, massive extension in supply. This perfectly corresponds to manufactured goods like books, cars, and televisions. Unlike drilling for oil, if the market price for TVs goes up, factory managers can rapidly scale output simply by telling their workforce to run longer shifts.
To lock in your understanding of producer responsiveness, here's a quick recap of the supply side. 0 is perfectly inelastic, totally fixed quantities regardless of price. Less than 1 is inelastic. Supply responds only slightly due to physical limits. Greater than 1 is elastic, where factories rapidly expand production to chase those profits. And infinity is perfectly elastic, where even tiny price shifts awaken dormant machinery to cause massive output changes.
You now have the exact framework to decode how the entire physical world responds to money. So, I want to leave you with this. Look around the room you're sitting in right now. Pick 3 items. Based on the 14 graphs we just walked through, which of those items have an elastic versus inelastic supply or demand? Keep analyzing your world like an economist, and thanks so much for exploring with us.